Okay, so we just learned about ionic bonding, where positive ions and negative ions are attracted to each other and stick together like little magnets. Opposites attract. Today, we're going to look at covalent bonding. Now, the word covalent, you can break down into two pieces. There's co and valent. For the co piece, I want you to think of cooperate. Cooperate. For the valent, I want you to think about valent electrons. Now the valent electrons are the ones on the outside. Valent electrons are on the outside. It's only the outside that matters in covalent bonding. It's only the outside that wants to be full, because remember, the inside is already full. So covalent bonding is cooperating outside electrons. They share. So when we think of covalent bonding, we're thinking of atoms that are overlapping with some electrons being shared. I'll show you what I mean. Here's oxygen. Oxygen, you remember, has 8 electrons. And if we draw it out, its atomic number is 8. So it's got 8 protons and 8 electrons. So we put our 8 pluses in the middle. And then in our first set of electrons, we've only got 2. And then it's full. And then we got 1, 2, 3, 4, 5, 6. And that makes 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So in our picture here, all I've drawn is the outside. We got 6. It's not happy, right? It's only got 6. It's not full. So the atom with the green electrons says, I'm really unhappy. I need more electrons. And so the atom with the blue electron says, okay, well, I could share 2 of mine with you. And you take a look. This atom, he's still only got 6. But this one over here, he's got 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outside now. So it's very happy, but this one's not. So this one says, oh, I need 2 as well. So it shares 2. It's still got 8. 1, 2, 3, 4, 5, 6, 7, 8. But now this one does 2. 1, 2, 3, 4, 5, 6, 7, 8. So they've both got a full set of electrons on the outside. So they're both happy. The only difference is they're joined together. They're joined together with a bond here. That pair of electrons bonds them together, and this pair of electrons bonds them together. So we say we've got a double bond. Here's fluorine. This atom here, it's only got 7 electrons. 1, 2, 3, 4, 5, 6, 7. So is this one. There's nowhere to steal electrons from. So instead, they share. Now this one's got 1, 2, 3, 4, 5, 6, 7, 8. And so is this one. Let's think about chlorine. Now chlorine, its atomic number is 17. That means it's got 17 protons and 17 electrons. So we've got 17 protons in the middle and then 2 electrons. Then we go to the next shell and we can fit 8 in there, right? So we put our 8 in. So that's 10. 2 and 8 is 10, and we put another one around the outside. Forgive my circles. And it can have 7 in there, so we've got 2 and 8 and 7 makes 17. So in the outside we're going to put 7 electrons. For each one. I expect you're already there, right? You've already figured out what's going to happen. This chlorine atom has 7 electrons. So is this one. They both need one more, so they share one. Now this one's got 1, 2, 3, 4, 5, 6, 7, 8. And so is this one. Okay, so now I want you to try nitrogen on your own, okay? Pause the video. So pause the video now and try it on your own. Okay, so nitrogen. Nitrogen's got an atomic number of 7. So it's got, 7. So it's got 7 protons and 7 electrons. So we'll put a nice plus 7 in the middle. So it's got 1, 2, 3, 4, 5, 6, 7. It's only got 5 electrons on the outside. Long way to go before it's full. So what we're going to do is we're just going to start sharing. So we'll take one of these and one of these. Draw a little box. Count up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so it's not happy yet, so let's share some more. Okay, 1, 2, 3, 4, 5, 6, 7. Still not happy yet, so let's share some more. 1, 2, 3, 4, 5, 6, 7, 8. So this one's happy. 2, 4, 6, 8. This one's happy. So in nitrogen we have a triple bond, right? Because we have 1, 2, 3 bonds. And that's covalent bonding. Remember, in ionic bonding, they steal electrons or give electrons away in order to get a full valent shell. In covalent bonding, they share electrons to get a full valence shell. In our next lesson, we'll see what difference that makes.